Welcome everyone. My name is Sahil Singh and today I will be explaining the topic of routing protocols from computer networks. What exactly is routing? So routing is the fundamental process that enables data to transverse across interconnected networks, finding the most efficient path from source to destination. Operating at network layer 3 of the OSI model, routing forms the backbone of modern computing network and makes global intercommunication possible. How does it actually does that? It requires a special device called router. It specializes that forward data packet based on logical addressing, primarily IP addresses. They maintain routing tables that contain information about available network paths and use sophisticated algorithms to determine the optimal route for each packet. Without routing, device could only communicate within the local network. Routing enables communication across different networks, ensuring data is delivered efficiently while minimizing delays and packet loss. Think of it as a GPS navigation, like a GPS system that selects best route based on distance, traffic, road condition. Router evaluate multiple paths and choose the most optimal one for delivering data. Mostly it uses the extra algorithm and other algorithms to find the shortest path and optimizing the route. What are routing protocols? Routing protocols are standardized rules that let router exchange network topology information. They enable routers to automatically learn and update routes instead of relying on manual configuration. By using metrics like hop count, bandwidth, delay, and reliability, these protocols ensure routing tables stay current and adapt to changes such as link failure or congestion. In essence, they act as a common language that allows routers to share information and make intelligent forwarding decisions. Why routing protocols are essential? Because of the four main reasons, which are automation, dynamic adaptation, optimization, and reliability. What is automation? It eliminates manual route configuration, reducing administrative burden and human error. Dynamic adaptation automatically responds to network changes, failure, and new topology addition. Optimization selects best path and metrics, ensuring efficient data transmission. Reliability provides alternate paths when primary routes fail and minimizing downtime. Three major type of routing. First is static routing. Uh, Routes are manually configured by network administrator, simple to implement with full control over routing decision, highly predictable and secure, suitable for small networks if you are planning for your local area networks, where topology remain constant, does not adapt to network changes automatically. Dynamic routing. This is the most important one and usually used across the globe. Uses routing protocol to automatically discover and update routes, adapt to changes such as link failure, congestion, or new devices. Highly scalable for large and complex networks. Requires more processing power and bandwidth, but provides flexibility and efficiency. Default routing. Used when no specific route is available in the routing table. Directs packet to the predefined gateway as fallback mechanism. Ensure packets are forwarded even when specific routes are unknown. Commonly used in subnetwork and small configuration. So we will study mainly about static and dynamic routing and their advantages and disadvantages. What are the limitation of each one? So here are those. Static routing advantages. It is simple to configure and understand, provide full administrative control, highly predictable behavior, more secure with less overhead, low bandwidth consumption for update. What are its limitations? It would be that it doesn't adapt to network changes, manual update required for failure. Time consuming to maintain as network grows, not suitable for large net. What are the advantages for dynamic routing? That will be automatically adapts to topology changes, scalable for large networks, fast convergence after failure, optimized path based on metrics, reduces administrative burden. What are the limitation of dynamic routing? It will be more complex configuration required, a higher resource consumption, security vulnerabilities possible, can consume bandwidth for updates. Routing metrics and path selection. Routing metrics are values used by routing protocol to determine the best path for data transmission. Different protocols use different metrics to evaluate available routes. These metrics allow routers to compare multiple paths and select the most efficient one, with typically lower metric values and indicating better paths. Some of the factors which it decides on are hop count, number of routers a packet must transfers to. They used basically RIP protocols, bandwidth, available data transfer capacity used by OSPF as cost metric, delay, time required for each transmission across the path, reliability, link stability, and error rate measurement, load, traffic volume, and resource utilization, cost, administratively assigned values based on various factors. So now let's see about the next slide. So the routing protocols are basically divided into two sections, intra-domain and inter-domain. The two intra-domain ones are distance vector protocol and link state protocol, and one routing protocol will be BGP, the Internet Routing Protocol. So we will go through each one of them one by one. First, distance vector protocol. How they work? Routers share their entire routing table with neighboring routers. At a regular interval, they rely on the Bellman-Ford algorithm to calculate the shortest path based on distance and direction. Its characteristic will be simple and easy to implement, slow convergence time, prone to routing loops, count to infinity problem, periodic updates only shows a RIP routing. Routing Information Protocol or RIP is the most well-known distance vector protocol. It uses hop count as metric with maximum limit of 15 hops or so, making it unsuitable for large network. Despite the limitation, RIP remains useful for educational purposes and small networks due to its simplicity. Link state and hybrid protocols. Link state or OSPF, how it works basically is routers share information about immediate links, building complete network topology, maps, uses Dijkstra algorithm for shortest path calculation. Fast convergence, accurate routing, no routing loops, efficient updates are some of its advantages. Use case will be mostly for large enterprises network requiring scalability and high performance. Hybrid model, which is EIGRP, how it works basically is combines feature of data vector and link state protocol. So it is a combination of the above two protocol which are mentioned use advanced dual algorithm for fast convergence, and which is a major advantage is fast convergence, reduce overhead, flexible metric calculation, and partial update. Use cases is basically used for complex networks requiring both performance and scalability. So it basically uses in large business models. Link state protocol like OSPF provide a more advanced approach by sharing link information rather than entire routing table. This allows each router to build a complete map of network topology and calculate optimal paths. Now, the last one, the network internet routing protocol. What exactly is BGP? Border Gateway Protocol, or BGP, is the protocol that powers the internet used for routing between the autonomous system. It classified as a path vector protocol that consider policy rules and path attributes rather than metrics and route vectors. What exactly is autonomous system is? It is the combination of different network topology working together worldwide, as you can see in the image here. Some of its key features are highly scalable for global routing, consider administrative policies, manages complex routing decision, handle internet scale topology, and require careful configuration. Some of the key takeaway which you can take from this lecture is routing protocol provide the intelligence that enable efficient, reliable, and scalable network communication. From just simple distance vector protocols like RIP to sophisticated path vector protocol like BGP, each serves specific networking needs. And understanding this protocol is essential for modern network engineering and design, and that we have seen in class also, that how important this routing protocols in our daily life. Thank you. This will conclude my topic. Now, to finally conclude and summarize the topic, I'll be discussing about current modern day use. And what we learn from this is basically for the current modern day use case, we will first see about the two major routing protocol, which are inter routing protocol and intra routing protocol. For inter routing protocol, we have two division of distance vector and link state protocol. Distance vector is still used in small or legacy networks for simplicity. It is used for teaching RIP protocols in universities. We also have learned in Cisco packet tracer about RIP routing in routers. For link state, it is widely deployed in enterprises and ISP networks for fast convergence and scalability. BGP is a type of inter-routing protocol, and it is a big backbone of internet, managing global network, what we see today between autonomous systems. What we learn from this is by studying this protocol, we have basically understood how network balance, efficiency, reliability, and how it scale over time and how it handles such issues. The future lies in intelligent, adaptive, and secure routing systems that can handle explosive growth in devices and data, which is going to be happening because of the AI. It will expand much more rapidly than we initially assumed. So it will be hard to come up with the solution, but modern day routing methods are still very efficient, ensuring seamless communication worldwide, which we are experiencing right now. Thank you, everyone. I conclude with this.